Hi everyone. In this video, we're going to take a look at how to use fundamental trig identities to simplify expressions. So let's get right to it. In this first example, we have a sine times a cotangent. All right, and we want to see if we can, like I said, simplify that a little bit. And our general process is going to be replacing elements of the expression with equivalent expressions from our reference sheet here. So knowing your identities really well is going to be really instrumental in success here. So right off the bat, let's look at a couple things. Sine is one of our more basic ones, so we're not going to be able to replace that one. But let's look at cotangent here for a quick second. Cotangent, we know, defined in a couple of different ways. We know that a cotangent is the cosine over the sine, but we also know that it is the reciprocal of tangent. So which one of these is kind of advantageous for us to take with us? Well, let's try one, because, you know, when in doubt, try something is going to be the mantra that we abide by in this section. So if we try to replace cotangent with 1 over tangent, and then we bring sine with us, well, we would get sine over tangent, and that wouldn't really be any simpler than the original expression. So we would consider this to be a dead end. It's not really getting us anywhere. So let's go ahead and try instead the other one. So replace cotangent with cosine over sine. Right? I should have done that in blue, actually, because that's my cotangent becomes cosine over sine. And, oh, we actually see something fun and exciting going on now. The sine here is going to divide out the sine here, and so what we're left with is cosine theta. So what this is saying is that the sine times the cotangent is equivalent to the cosine of theta, because we simplified this to get that. There are a couple of different ways to verify that we are accurate, which we will discuss in class. So make sure we come with any questions in class about this one. And in just a second, we will get started looking at example number 2. So let's take a look at example number 2 here. Now, in example number 1, all of the variables were just simply thetas. So they played nicely together. They interacted nicely together. And that's something to keep in mind whenever you are combining and simplifying and multiplying and dividing trig expressions. You do have to have a matching angle, a matching variable. And in both of these cases, in A and B, we do not have that. So what we have to do is somehow get rid of this 90 business going on here and make it just say theta. How can we change a 90 minus theta into just the theta? How can we remove this 90 thing? Well, if we go back here to the cofunction identities, it does exactly this for us. So what we see is that some expression of 90 minus theta is rewritable as just a theta in all of these instances. So which one is relevant to us right now? Well, the sine of 90 minus theta is the cosine of theta. So using a cofunction identity, the cofunction identity says that the sine of 90 minus theta is equivalent to cosine theta. So let's take this out and put cosine in its place. Well, now what? Well, just like we did in example number 1, now we're going to need to simplify a little bit, or substitute a little bit, that is. So tangent, let's take out tangent and write tangent as sine over cosine. That's one of our basic quotient identities. The definition of tangent, well, one of the definitions of tangent is that it is equivalent to sine over cosine. So we bring our cosine down from this step, And now cosine divides out cosine, leaving us with a nice, simple expression to end the problem with. Let's look at one more example here of an identity or an expression that has some small differences here in the angle. So just like in part A, we looked at a way to kind of get rid of the 90. Let's look at a way to get rid of, quote unquote, get rid of the negative. And the pile of identities that have to do with negative angles are the symmetry ones here, odd and even identities. You might remember the odd and even functions from Algebra 2 with symmetry to the origin or symmetry to the y-axis. That's where these come from in trig, which we'll again talk about in class. But let's find the one that has sine of negative x in it. It says sine of negative theta, but as long as you're keeping your variables consistent, they are interchangeable. So we know from the symmetry identity that the sine of negative x is equal to negative sine x, or opposite sine x. So we're going to take this out, insert this in its place. We're going to bring our cosecant down, unchanged. And now what? Well, some of you might be clever enough to be thinking ahead. Sine and cosecant are reciprocals of one another. Product of something and its reciprocal is 1. But let's do it with fidelity. We've got cosecant being equal to 1 over sine. So let's take out cosecant, replace it with 1 over sine. Let's bring our negative sine down. And what we've got here, let's go to green. We've now got negative sine over sine equals negative 1. And that would be the final answer. The most simplified version of this original expression. So again, we'll verify it in a couple of different ways in class. But what this is saying is that the sine of opposite x times the cosecant of x is equal to negative 1.